Time to build another expansion for this Amiga 500. So far in this machine, we've built and installed an RGB to HDMI. We also have the Gotta Go Fast RAM card. That's 8 megabytes of fast RAM. And the last thing I want to add to this machine is an IDE adapter. That's this thing, IDE68K. So let's see about getting it put together. But just before we do, go ahead and assemble this board that was very kindly donated to me by Sparks UK. Thank you very much indeed. I picked up a set of these, or well, should I say Santa bought me a set of these. Like a head mounted thing with different sets of magnifying lenses, and hopefully this will just make things a bit easier rather than having to use the big magnifying glass that you would have seen me use before. This has 1 times magnification up to 3.5 times. Let's start with somewhere in the middle, shall we? Just 2 times magnification. Yeah, I can't see anything through these. That is very blurry. But if we hold this up to about there, about that sort of distance, that is brilliant. Crystal clear and magnified, but as soon as it gets out to about there, it's just a blurry mess. So yes, I would dare say using these for any length of time will cause you a bit of eye strain, but let's see how we get on. No, you look like an idiot. Okay, maybe it's me. So same as always, we're going to start with the CPLD. Now, last time when I built the Gotta Go Fast RAM board, I suggested that it might have been better to put all the small passives on first, but when I built the second one of them, this one here, I did try and do that. I tried to put all the little capacitors and bits and pieces on first of all, but when it came to mounting the chips, especially here where I was mounting the memory chip, all those capacitors there, they all lifted off again just due to the heat. So definitely, if you're going to be building one of these things, put all the larger components on first, then you can come back and do all the chicken feed. So there's our chip that has to go on there. Pin 1 is down this corner, denoted by the circle there, but also you can see the outline of the chip. That corner is chamfered. That's the same on the real thing. There's a dot in that corner, and that corner is also chamfered. That goes on something like that. I'm going to line it up here under the magnification and just use a bit of Captain tape to help hold it in place. Then we'll try soldering one edge of it. Okay, that's it, pretty well aligned. Let's get a bit of flux on. And then same as before, we'll just tin up the iron and see about getting this stuck down. Okay, that's one side done. And as per usual, I forgot to turn on the fume extractor. Okay, that is on. I'll just tidy up the flux there and then we can try and program it before going any further. This thing though, well, it's taken me, what, 5 minutes maybe to put that on. And in that time, using that, my eyes are absolutely burning. So that may not have been the best purchase, to be honest with you. I do think the separate magnifying glass is better, and only because you can set that to, a distance and then it's in focus constantly. This thing here, if you're moving, back and forward your head, it's in and out of focus constantly and it's just straining your eyes. So let's see if we can do the rest of this without having to use this thing. That is a bit of a shame. Okay, let's get this programmed. So the Pi's running, the SD card is in there, and the JED file we need is on that. This is just the same setup that we used last time when programming the Gotta Go Fast RAM card. So that connects off to this point on this card. I'm just going to hold that there with a bit of tension. And we're just following the guide again on Live2's GitHub. This one here, I will post a link to it in the description. All this is already set up. All we need to do is run this command, replacing buster.jed with the one for this. So I'm connected to the Pi here, and that's what we need to run. Simple as that. Next job then is just to stick all the rest of the SMD components on. Then we'll have a think about the through-hole stuff. That's nearly all of the surface mounted stuff fitted. There are a few pads over here that are going to remain unpopulated. Those are just for adding an LED to show hard drive activity, but I'm not going to bother with that. Capacitors C1 and C3, those were incredibly tight to get on there. The actual cap themselves is exactly the same size as the footprint of, the pads on the PCB. Maybe I ordered the wrong parts, not sure, but they're on there anyway. And the one other thing that is missing is IC2 in between them. That is the space for the voltage regulator. Now, as you know, those 3.3 volt voltage regulators are out of stock more or less everywhere, and it's going to be the guts of August this year before, Mouser, DigiKey, all the usual sort of sources, before they have any stock. So same as when we built the fast RAM board, we're going to have to jury rig a through-hole component into this position. Now, just because things are so tight in there, what I think I'll do instead is make off the legs of this onto these two capacitors either side. Well, it's on there, and this is what I've done. So just that leg there, which is the output, the 3.3 volt, I've put that onto the side of that capacitor there. The middle one, which is the ground, I was able to get onto the ground pad, and likewise the 5 volt, which is on this side, the input, I was able to get that onto the pad as well. Just put a little bit of heat shrink over that leg of the regulator there, just where it's sitting on top of that capacitor, just so nothing would ever short out. But we can test it as well, just to be sure. So with the meter in continuity, that one there should be the 3.3 output, and I can test that over to here, and that's right. That one there should be the 5 volt input, and we can test that to there. Yep. And then that middle one is the ground, and we can test it to there, and that's fine. Also just double check there's no shorts between them, and it doesn't seem as if there is. Hopefully that will work. So then it's just a matter of doing all the through-hole stuff. Now, like me, you might expect this thing to sit in the Amiga like that, with the IDE header on this side pointing into the case. But no, this thing actually goes into the Amiga like that, upside down, and the IDE connection is on the left. So we need to put something on there to push this down into the socket. Now what you've probably seen other people doing is using the individual pins. I did use those on the other Gotta Go Fast RAM card, these things, and as you can probably see, not two of those are straight. They are a bit of a nightmare to work with. So what I thought I'd try this time is use these. Now granted, they are a bit long, But just with them all together, you know, being connected here, just thought it would help hold things together and hopefully just make it easier for getting those down into a socket. I may wind up having to trim a bit off those because they are quite long, aren't they? The IDE header itself does go on this side. Need to just double check the orientation of that. I think it's that way around, but I will check that. And then the other thing we need to do, because this isn't just as plug and play as the Gotta Go Fast RAM, we need two signals off the Amiga's motherboard, INT2 and OVR. So I need to connect something like this in there, and then we can run a set of wires from that to the suitable location on the Amiga's motherboard. Lots of soldering to do. I'll get on with that, and then it'll really just be a matter of testing it to see if it works. Well, that's it all together, but before we can test it, I need to make off a couple of wires onto the motherboard here for those two signals, INT2 and OVR. Now, handily enough, we can pick them up just over here on the edge connector. And on the top side as well, pins 17 and 19, which is the 9th and 10th ones down on this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those two there. And to make it even easier again, we have two little vias there that we can make the wires off onto. And those will be going in there. Something like that. The blue wire will be OVR and the white wire will be INT2. But while I'm waiting for the soldering iron to heat up, we have another problem. And unfortunately one of my own creation. That's the wrong type of socket. That's not wide enough. It's the right amount of pins, but it's not wide enough to take an IDE connector. That was a bit stupid of me. There is the correct sort of one there. So you can see the width of that. That just has additional space at the ends to allow, you know, the connector to go in. Now, I'm not going to attempt to desolder that. Anytime I've tried to desolder something like that before, it has always turned out to be a bit of a disaster. So what I'm going to do instead is just cut the plastic on the sides. Now with those ends gone, that can go in there like that. Although there is going to be a cable there, and we're going to put this somewhere different. But even the cables have the wider connector on them, so no choice but to butcher that socket a bit. Oh well. Right, those cables are on, ready to go. I dropped a little bit of solder onto the gold plating of the edge connectors there, so there's no way to get that back off, unfortunately. Another silly mistake on my behalf, but well, I've tidied it up as best as I can. See, if you're going to be doing something like that, put a bit of Captain tape over, you know, your edge connector there, so you don't make the same mistake that I did. So we'll lift this CPU out. In fact, you know what? I'm going to lift that Raspberry Pi there out of the way. Part of the RGB to HDMI. We don't need that at the minute. Just to give us a bit more room to work. There's the Gotta Go Fast RAM board that we built before. That can stay there. And then this thing, all being well, should sit in here. Yeah, I'm going to have to shorten them up though. They're far too long. For testing purposes though, we can leave them like this. It's just going to be tricky to get it into the socket. Maybe easier, you know, trying to get it into the socket on the motherboard. Get this thing out. Yeah, we can't leave that like that. That's far too tall. And I can't install that again, because that's in the way. Can we even install a CPU? Yeah, that'll go in. Suppose we can test without the fast RAM. But there is another problem. This machine is running Kickstart 1.3, and you'll never guess what that doesn't support. So yes, there is no support for IDE on Kickstart 1.3. You need to get the Kickstart version 2. That would be found in the A500 Plus before they added that support. So what I've done is just burnt a ROM here, and I've just stuck 3.1 on that. Now, because this is a Rev 5 motherboard, there's a little bit of modification required to get this to work. You need to bend out pin 31, connect that to VCC, and connect pin 31 where it goes into the motherboard round to pin 1, which is address line 17, I believe. So that will go in there like that. That will go in there like that. And that just has a very basic version of Workbench 3.1 installed. So let's see if this is going to work. Keep an eye on that middle LED there, the amber one. That shows the drive activity. Looking good. It's accessing it. That's why I didn't bother putting the LEDs on this, since there's LEDs on that. And yes, we have booted into Workbench. So that is seemingly working fine. Now you might notice that I don't have any power connected up here. That's because this particular type of CF adapter, well, it can also derive power from pin 20 on the IDE header, and the IDE68K provides power through pin 20, so no need to hook up external power. That just saves more wires running across the Amiga's motherboard. The only other place you could pick up power would be over here, where the floppy gets its power from. Or I suppose you could always pick it up locally on that edge connector as well, but it's just more wires you gotta connect to the motherboard. So everything's working. We could just leave it with Kickstart 3.1 in there, but I've got an idea. You see, of my Amigas, one of those 1200s is running Kickstart 3.1, the other's running Kickstart 3. The 500 Plus over there with the Pi Storm in it, well, it's running Kickstart 3.1, and the CD32 that's hiding down the bottom end of the man cave, well, it is also running 3.1. So let's do something a bit different. This 500 originally had 1.3 on it. As I said earlier, there is no support in there for IDE, but let's see if we can do something about that. And if we're going to patch Kickstart 1.3, well, we're going to have to download some stuff to help us. So we'll jump on to Aminet, and it's this archive that you're looking for here. Kick13 SCSI patch. I'll leave links to all this in the video description, but this one here contains the patches that we need to apply. We need this, get SCSI 11. That's going to extract the SCSI.device from 3.1 Kickstart that we need to apply to the 1.3. And it's that SCSI.device, which in itself is essentially the IDE driver that allows the Amiga to see the IDE drive, or in this case, the CF card. And then we also need this tool here, Gpatch. That's just going to apply the actual patches. So download all those LHA files and then extract them out into a folder. I've got them in here, Amiga Kick13. And we're also going to need the Kickstart ROM itself. And in particular, it must be the 256K version of it. And yes, I've been calling it Kickstart 1.3, when in reality it's actually known as Kickstart 34.5, but everyone just calls it 1.3, 3.1, etc. So that's what I'm calling it. But anyway, browse to where you extracted the SCSI patches. There's an HTML file in here with some instructions, so open that. And in particular, it's these instructions here, which we are going to be following. Don't need to worry about that first one, downloading the patches, as we have already done that. So we'll jump into WinUAE, and I'm just going to start my basic A1200 configuration. This is just the same basic 3.1 install that you've seen earlier. Now I'm going to run all of this from the RAM disk, so I'm just going to jump into Dopus and copy everything that we need across to the RAM disk itself. So we need get SCSI, we need gpatch, we need the patch files, so that one, that, those two, and then all of these. We're only going to use one of them, but we'll figure out which one in a minute. And of course we're going to need the Kickstart itself. Then once I've done that, we'll just jump into Shell. First thing I want to see is which version of SCSI.device that we have here, and it is version 40.12. So we can move to the RAM disk and start applying these patches. The first command then, okay, that worked. Now we need to extract the SCSI.device from our Kickstart ROM, and it is just as simple as get SCSI. We can list the contents here, and you can see it there. It has extracted it, that's it, SCSI.device. We then need to apply that SCSI.device to a ROM file. And it is version 40.12 we're working with here. So it's that patch that we need to apply. And then finally, we just need to merge the SCSI.device.rom with the patched Kickstart. And that should be it. If we list the contents again, there is our new ROM file. And you'll notice now that it is a 512K ROM. So we're finished with that. We can jump back into Dopus again. And I can copy our new ROM file. There it is there. We can copy that back to the PC directory. And there it is there. Now we're not just ready to burn that to one of the EEPROMs just yet. We first of all need to byte swap it. And to do that, I'm going to use this little tool here, byte swap. And that's it there. That's the one that we need to write to the ROM. So let's get that done. Then we can stick it into the Amiga and see, first of all, if it's at least going to post. Okay, I have written the new ROM onto this. And because this is now a 512K ROM, rather than the 256K of the original 1.3, I have had to do our little modification that we also had to do for Kick 3.1. So let's get this in here. And let's just see, first of all, if it's even going to post. Power on. Yeah, looking good. All we'll have to do now is set up this with Workbench 1.3. Well, since that works, let's set up the CF card with Workbench 1.3. We'll do that back on the PC here just to make things simple. And we're going to use WinUAE to help us. Now we're going to need the ADF files. That's just the Workbench disk itself. But because that version was never really intended to be installed on a hard drive, well, there's no HD Toolbox utility in there to set up the drive. So for that, we're going to use this instead. Workbench 2.04 install disk. We're only using that now for its HD Toolbox. We are going to be booting to Workbench version 1.3. Before we do anything though, let's run diskpart. Our CF card is disk 2. And let's just clean that, just so we are starting from scratch. Right, in WinUAE then, let's just set up a configuration that, well, more or less matches our A500. So 68K processor, let's go more compatible, and let's put it on cycle exact. Chipset is OCS, but chipset extra, well, we can't pick A500 here because those profiles here, to the best of my knowledge anyway, will disable the IDE or hard drive functionality within WinUAE, and that's because those machines themselves, well, they didn't have that feature. So I'm going to pick A600 there. Advanced chipset, we're not interested in that. For the ROM, let's take that Kick13 SCSI ROM that we created earlier. For RAM then, let's just match what this machine is. So it's 512K chip, 512 slow, and it will eventually have 8 meg of Z2 fast. Floppy drives, well, we can mount our 2 disk images in there. And as I said, we are going to boot to Workbench 1.3. And then under the hard drives, we can add our CF card. And this must be changed to the Commodore IDE. So let's open up the install disk into Tools, and we're looking for HD Toolbox. Change drive type, we can delete this old one. Let's define new, reconfiguration, continue, and OK. In this version of HD Toolbox, you need to select that and then you can click OK. We now want to partition the drive. Delete that one for now. So partition DH0, let's make that, what? 124 megabytes, that's loads. We're going to change the name of it to DH0. And of course we need to change this 0x1FE00, that's the max transfer. And we're just going to use the fast file system here. Then we'll just create another partition and that'll just fill the rest of the drive. We'll change the name to DH1. And again, change that max transfer 1FE00. Don't forget to hit return to confirm what you have entered. So that's it. Save the changes to the drive and a reboot is required. We can then jump into Shell and we can use this to format the disks. So you can see the syntax of it there. So it's format drive DH0. The name, well, what we'll call it, OS13. And let's just do this quickly. And then let's just do the other one. And then to install OS 1.3, all we need to do is copy DF0 to DH0 and all. Okay, that should be it. So end CLI. And in case you're wondering, the reason that I formatted those drives from Shell rather than, just selecting the icon and right clicking looking for format, that's because it isn't here. You can initialize though, which I suppose is the same thing. But if you do it here from that menu, it will always do a low level format and take, what, quite a long time. Let's just say that. But we can test this within WinUAE. So all I have to do is remove those two disks, restart and start, and then hopefully it'll just boot off the CF card into Workbench 1.3. Yep, it seems to be working. Not really sure what that invalid is all about. But there we are, it has booted. So let's get that CF card into the Amiga and fingers crossed this works. Okay, moment of truth. Is this going to work on the real machine? No. What about if we reset? Nope. Not looking good. Let's boot into sysinfo and just check to see if it can find DH0. So let's go into drives. And no, it is not seeing them. Well, it seems that those instructions we were following earlier are maybe only part of the story, because doing a bit more digging, I found this post on EAB from September 2017, and it seems that this guy here was trying to do the same thing that we are. He's using an IDE68K on a machine similar to an A500, his A1000 with a Phoenix board. So what we need to do is follow the instructions in Kick 1.3, which we've done. But before we byte swap, we need to open the Kickstart file in a hex editor. That's what I've done over here. And we need to modify it. And that's because the code that we're going to enter into the Kickstart file, well, that must be executed before scuzzy.device initializes. It somehow enables Gale. Without it, scuzzy.device does not recognize Gale and does nothing. And that's certainly what was happening on our 500, wasn't it? It was doing absolutely nothing. So let's just try this. Right, look for the ROM tag structure at the beginning of the file. Starts around 50 and reads that. 4AFC, yep, that's it. So what we need to do is follow this through and then write down the values YYYY, as in the last 4 values there. And that would be those there. 0076. Give me a notepad. We then want to search for the end of the scuzzy.device code at around 2900. The data becomes all Fs. Overwrite the first of the Fs with the following. Right, let's find this. There we are. So starting from there, I need to enter all of that. And then instead of YYYY, we're going to note down what we did in step B, which is 0076. Right, now we need to note the location of the data we just entered. Should be around that from the start. Need to note the exact offset from the start of the file to the first byte, 48, which, yeah, just the start of that. Okay, so that's that one. And if we select that, you can see down here the offset is 2A, 2C. So we then need to go back to the ROM tag structure and replace our 0076 with the offset we just noted. So that was there. 2A, 2C. He goes on to explain some background. So what is actually missing from the combination of Kickstart 1.3 and SCSI.device from some later Kickstart is the Gale initialization. That code there, and what we have entered here, just adds that code into the ROM. The procedure above adds this code at the end of the SCSI device hunk and changes the initialization pointer of the ROM tag structure to run this code, which in turn jumps back to the original initialization routine. Please be aware this is a quick and dirty solution. There is nothing wrong with quick and dirty solutions. I just hope that this works. So we can save that. You can byte swap it. Then I just need to burn it to another ROM, and yeah, hopefully this works. So yeah, that didn't work. It is still not seeing the CF card. So I went back to this EAB post and reading on down it a bit. I'm wondering, are we maybe using the wrong SCSI.device? So I've downloaded this SCSI patch file. This is telling us to use SCSI.device 40.5, which is in Kickstart 3.1 for the A500. So let's try that, and well, if that doesn't work, I'm afraid I'm out of ideas. We'll just take our A1200 configuration, but we'll change the chipset to ECS, and we'll change that ROM to that one. This is definitely using SCSI device 40.5. Right, I'm just going to go ahead and patch everything exactly the same way we did before, but this time, rather than applying one of these SCSI.device patches, it was that one there that we applied last time, I'm instead going to apply the one from that EAB post, which is that one there. And that's us. That's our new Kick 1.3 SCSI ROM, but this time it's got SCSI.device 40.5. So I'm going to go ahead and edit this the same way as we did earlier. Then we'll byte swap it, burn it to a ROM, and hopefully this time it'll boot. Right, let's get this one out of here. Hopefully for the last time. Come on, this is going to work. While I was waiting for that to burn, you'll notice that this thing is a bit shorter now, and the gotta go fast RAM is in below it. I just trimmed all the legs down on that and then stuck it in there. Let me tell you something, it is never coming off that fast RAM board. Those pins are incredibly tight down into that. So let's just hope this works. I don't know how I would get them apart again without risking damaging one of the boards. Anyway, that's in. Come on. Positive thoughts. This is going to work. It's booting. Is it? Is it booting? It's accessing. Hasn't done that before. Come on. Oh yes. It's working. Is it going to make it the whole way into Workbench? Of course it is. Fantastic. We finally have Kickstart 1.3 patched with SCSI.device. Seems that it needs that SCSI.device 40.5, the one from the A500. We had to apply that Gale patch as well to it, didn't we? And that seems to have sorted it. Brilliant. Excellent. I am all sorts of pleased with that. It works. There is one more obstacle to overcome though, and it's this CF adapter. We can't leave it sticking up in the air like that. So let me get that off. And I've been on the 3D printer and came up with this. So that'll come off. That replacement door will sit on like that. It has this bit sticking out of the side of it, which is for the CF adapter. So that'll go in there like that, and I'm going to mount it in place just with a bit of double-sided sticky tape. Then the lid goes on, and we can access the CF card from the side of the Amiga. I just need to run an IDE cable from there over to here. Well, I'm really pleased with how our Amiga 500 has turned out. We've done quite a bit to this machine over the past several months, haven't we? We've got the RGB, the HDMI in there, the 8MB of fast RAM, and now the IDE68K with a CF card hanging out the side. I'll leave a link to Thingiverse where you can download the files for this. Should you want to print one for yourself, you can get them there and work away. The only other thing that this machine probably needs, in fact does need, would be a 1MB chip RAM mod. And I know I've been saying that for quite a while, probably since we first opened this thing up. But I still need to get that other Agnes, so I will get one. And then we'll do one more video with this machine to do that chip RAM mod, and then that will be it. So until then, all that remains for me to say is thank you very much for watching. Hopefully you enjoyed this video. If you did, I would appreciate a big thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.